Next comes the maximum weighted considerations. So maximum weighted considerations here, Hamming distance. You need to know the definitions of this. They may ask you. This is given by D of C1, C2 between the two codes is a number of positions in which they differ. If you consider an example like 1010 and 1101, Hamming distance is nothing but how many positions they differ. Both of them differ. That is known as Hamming. So you can see 1 it is same, 0 1 it is different. So 1 and here 2 and 3. So the distance is 3. How many bits they differ? Simple. Next comes the Hamming weight. So Hamming weight is nothing but the code vector is a number of non-zero elements in the vector, like 11001. In this number of non-zero elements is 3. So hence the Hamming weight is 3. Next, the minimum distance, that is D minimum. It is the smallest Hamming distance of the linear block code between any pair of the distinct code words. So D minimum is minimum of WC where C is not equal to 0. Next comes the minimum distance and parity check. So we know that C into H transpose is 0. H column is given like this. The column of H corresponds to ones in C must sum to 0 vector. So Hamming weight of C is given by number of columns involved. Smallest number of columns whose sum is 0 determines the D minimum. Now the decoder strategy is the closest code word rule. Here the minimum of D, that is CI and CI, it's a minimum distance decoding. This D minimum, it determines the correcting capability of the code. The sphere interpretation, here each code word is surrounded by Hamming sphere. If that does not overlap, that is a case 1 where it will be greater than 2t plus 1. If there is overlap, it is less than 2t plus 1. Next, we are having the results as D minimum. It should be greater than 2t plus 1 and t should be less than D minimum minus 1. Shift that and you will get. This is the quantitative meaning of the error detection capability. Next comes the syndrome decoding. Here in the decoding part, let this be C to CK, 2K will be all the code words, R will be my received vector, 2N will be possible received vector. Then the receiver partitions these into the disjoint subset as D1, D2, and D2K. So algorithm here, how does this syndrome decoding work? This has been asked in one of the paper algorithm. Here, so firstly, you need to find the S is equal to R into H transpose. Then identify the coset leader, that is C0, corresponding to the syndrome S. E0. Next, you need to find the C. So for C, it is what? R plus E0. So hence the decoded code word is done. So let us see some of the problems related to that. Here 6,3 and whose generator matrix is given. You need to find all the code words, Hamming weight, Hamming distance, minimum weight, and draw the encoding circuit for that. So this is one of the problem. You can try. This is just easy. How to find the Hamming weight and Hamming distance. Just count the number of based on the definitions what we have learned. Just do it. It is easy. Next comes the codes. Here this is done just now and now here. Design we need to design A, that is n comma k Hamming code, the minimum distance of D minimum, and a message bits of length 4 bits. So k is equal to 4, n is equal to 2 power n minus 1 k. This is how we get n as 1, n as 2 till we take n as 7. So here we have n is equal to 7 till we have to do until we get it as 7 is equal to 7. So hence it is defined that n comma k is 7 comma 4. H transpose is given by what? P into in minus k. P is not, we don't know. N minus k, 7 minus 4, 3. Identity matrix. Now we need to choose the parity matrix. How to choose it? 2 power n minus k is 8. So here you can observe based on the thing that you should not get error, it should not get repeated, you have to identify the matrix. So here just observe it. This is the code that we write as usual for 0, 1, 2, 3, 4, 5, 6. So here this lines are all, this first one cannot be possible because no errors. In the second one, here this is already been repeated here, and third one it's repeated here, and for this one is repeated here. So these three we have to leave, and the remaining lines will be our parity matrix. This is how we choose our parity matrix. So based on that, find out the H transpose. We know C is equal to D into G, J is equal to IK into P. Find out the generator matrix, find out the C using the code word, find the message vector and detect the error. To detect the error capacity, d minimum minus 1. What is d minimum here? 3. 3 minus 1 is 2. So error correcting capacity is d minimum minus 1 by 2. That is 2 by 2 minus 2 by 2. That 3 minus 1 is 2 by 2. So it is 1. Let the received bit will be, let us consider 1 r. So S is equal to R into H vector. Here third bit, you need to change the third bit. So by comparing the H transpose in the third bit, we get this and we change this. So this is how we do it. Next comes syndrome decoding. As I explained the algorithm in the previous notes itself. We'll move on to some of the properties of the standard array. Here the array consists of 2 power n code vectors, which is positioned into 2 power k disjoint cosites. Property 2, the first entry of each row is as cosite leader and it represents the correctable error pattern of a particular code. Property 3, each element in the standard array is distinct, therefore different columns in array are disjoint. Property 4, all the 2 part k errors or patterns in a single row will have the same syndrome. So looking to the property problems, 6,3 block code they have given, you need to construct a standard array. So for first 6,3, the code words are, we need to solve in the beginning itself. So here, you need to write down the H transpose. For the H transpose 6,3 means, you need to note that this is N and this is K. So based on that, you need to draw the identity matrix and then solve it. This is the generator matrix that we have got. And from the description problem, we know it is H transpose. This is given by this. And here you have to draw the syndrome, then coset leader C2, C3, C4, C5, C6, and C7. So decoding using the standard array. Here considering an R vector has some received vector and the syndrome is given by what? R into H tran. So terminate, you get the error and change that bit. So this is how you get repeated same type of questions. Next part is the cyclic code and the major important part. The advantages here is the design of the encoder and the circuit are made more simple, which involves a shift register with a feedback connection. So using this, it is possible to design a codes with the useful errors, correcting the properties. So next is definition, how we can write it is in minus k is a linear block code. It is said to be a cyclic code if every cycle shifts the code is also one of the code vector. That's it. It's simple. So general representation of this can be done using the code vector is represented by V. So V0 to Vn minus 1. In the cyclic code V1, that is Vn minus 1, it starts in for 2, Vn minus 2 for Vi, Vn minus I2, Vn minus I minus 1. So each code is represented as a polynomial with variable x. So then what happens? It becomes Vx. Vx is given like this. Some of the examples you can solve for the modular 2 algebra you can use. Here is, let us consider one function is given as x plus 1 and another function is given as x cube plus x plus 1. You just have to multiply. X into x cube is x power 4, x into x is x square, x into 1 is x, 1 into x cube is x cube, 1 into x is x, and 1 into 1 is 1. So from this, simplify it. You can take x as common here and that becomes what? 1 plus 1 modular addition is 0. So hence we are left with x4, x3, x2 and 1. Then multiplication of again another two function is given. You will multiply these two. If you are having two common variables, you need to take the common out and that becomes 0 because modular addition 1 plus 1 is 0. This is how you do. In the division, let's take an example. This is my function 2 and this is my function 1. This is function 1 that I have written and this is function 2. Here what happens here is first x cube is there. So what to be multiplied here, added here, it has to be x cube. So x cube into x cube is x power 6. Similarly, x into x cube is, so okay, sorry, next is x power 5. To that what you need to add for x is equal to x power 2. So that is x4 plus another one is x cube. Basically, you have to multiply this with this and you will get the quotient and then you cancel it out and you get the remainder out of that. And similarly, continue it, go on doing it and finally you will get the remainder and the quotient. Next is the properties of cyclic code. Here the first property is it is the cyclic code exists a generated polynomial of degree n minus k, and it is given by the equation of generated polynomial like this. And the generator polynomial is cyclic in the factor x bar n plus 1, that is g of x into h of x, the parity check polynomial. And then the generator matrix of a degree n minus k is a factor of x bar n plus 1, then it generates n minus k cyclic code. Then cyclic code is non-symmetric format and can be generated using this equation. Then a cyclic code is a systematic format and can be obtained like this. These are the general things that can be written. So next, non-symmetric format means here 7,4 you can say it is 2 power 4, 16 code vectors. Then the length of the each code vector is 7. So code vector is what Vx is equal to d into Gx. As I said, d is being given. Each one will be d0, d1, d2 and d3. So now based on this, you have to write the algebra equation. That is how when it is 1, first one is 1. So you write it as 1 into x power 0. So x power 0 is 1, so it is 1 only. Next is 1, here it is x, and next is 0, so 0 into x square and 1 into x cube. So this goes out. So finally we are left with 1 plus x cube. This is my equation of p of x. Now g of x will be given in the question only. So you will multiply both of them, modular addition and multiplication, and then the addition, then comes the answer. So final b of x is there, no? That also you need to convert it back here. Like 1 plus x, 1 into x naught, that is 1 only. Next comes x1 into, we are having any coefficient? No. x2 into 1. So here based on this, you have to take out this binary numbers and write the code here. Similarly, see again, d is given, you need to convert it here, apply to this equation and find it out and get this back. This is how we have to do. So here I am considering 1 or 2 d vectors and doing the same way. You have to find out for all the message signal, you have to find out the code vectors. In the systematic format, if you want to do, then you have to consider the d. D has given us with this equation. Now for this equation, you need to apply this formula x power n minus k. It is x power n minus k. Here it is x cube. X cube of this d of x divided by g of x. Multiply it inside and divide by the modular division. And finally, you will get the quotient has this. So v of x is given as what? R of x into d of x. So r of x is 0, 0, 0. And my d of x is x cube. So x cube is 1, 1, 0. So based on that, you will just write the v vector. Similarly, for that also, you will get the v vector. So based on that, you have to write again the table. And finally, we have to prove it out that x power n plus 1 is x power 7 plus 1. You both of them, you multiply it. And we know that x power n is equal to g of x into h of x. So h of x is x power 7 plus 1 divided by this g of x. So hence q of x is equal to h of x is equal to this. So hence it is proved. Next is the generator matrix and the parity matrix as cycle codes. So let us consider 3 matrices as g of x and x into g of x, x square into g of x, and x cube into g of x as these 3 polynomials, and these are the code vectors of that. Now for the generator matrix, write down all the things in the same way. So to make the generator matrix in a systematic form, identity matrix. Next, add 3 rows with the first column C4 to replace the third column. So that gets replaced. So now the fourth, add 1 and 2 with the fourth column, and that changes the value of the fourth column. And next, similarly, now you got the D, now you got the G matrix, substitute, you will get the vector. So this method is also generates the same code vector that is generated by systematic. Same answer we have got here. Now for the parity check matrix, go with the same flow. This was all about the explanation. Next, encoding circuit for n comma k cyclic codes. So this is the formula for encoding circuit. You need to draw a circuit. To get the reminder, we need to do the division operation of this. So to design the encoder circuit, firstly we need R. These are the flip-flop that make the shift registers basically. Then the modular 2 adders, and then we need GI, generator matrix, that is switches. If it is open means it is 0, if it is closed means it is 1, and we need AND gates. So how do you design is, we place the number of shift registers that is required first. After that, we provide the output to the channel, and then we set one gate here and we enable it. So this gate, along with the number of G0, G1, G2 and Gn minus 1, how many are needed, these are added. So this depends on whether it is 1 or 0. If it is 1, it is closed like this. If it is 0, we just open it like this. We need to open it, we will not close it. So the operation and the working of that is given here. Pause that and you can, if you read, you can understand. It is easy. Now let us solve one thing and design it. G of x is given like this. So based on this comparison, you can write G0 is what? 1. It is G2, G1 it is 1. What is G2? It is 0. And this is 3, that is 1. Now to design the encoder circuit, we need n minus k flip-flops, that is 7 minus 4 is k flip-flops. The last generator used is Gn minus 1. This we need to use the modulator addition. So based on this, what we know, we need only G0 and G1. So based on that, what are the R0, R0, R1 and R2, and here it is given to the code vector and the channel, that is output to the channel, and then the message is given as input to here, and here it is gate is given, it is enabled, to that G0 and G1 is attached. So to the message vectors 1001, the shift registers contains, you can just do the shift registers content and the reminders that are obtained here. This is how you solve the generator matrix problem. Another one, 7,3, we'll look into. Here, this is the equation that is given. So here, based on that, we need 4 registers, shift registers. I'll place 1, 2, 3, 4. And Gn minus k, so we need 3 G vectors, so 1, 2, and 3. And those values, here you can observe G1 is 1, G0 is 1, G1 is 1, G2 is 1, but G3 is 0. So this is how you can write down the circuit. So this was all about this module. So it is easy, but you should know how to solve the equations. So syndrome computation, this is the last topic that you can refer into. Almost in the whole previous year papers that we have referred, you have to know how to write the syndrome n comma k cyclic code and its working, how that works in that order. So this was all about the module 4. I hope you have understood all the concepts. Thank you for watching. Do like, share and subscribe to Exam Ignite. See you in the next video.